Okay, let us do our third type, which is problem based on distance, speed and time. Whenever the problem is based on distance, speed and time, we have a formula which is distance is equal to what? Speed into time. And from that formula we can derive other two formula also. Speed is equal to distance upon time, or time is equal to distance upon speed. So all these three formula are same only. Now we need to understand one thing, okay, that you can add distance, you can add time also, right, but you cannot add speed. Just remember this thing, that you cannot add speed. Here we don't need to do that thing, but still you cannot add speed, or you can add only distance and time. So let us solve this problem. How to do this? Okay, a train travels 300 km at constant speed. If the speed increases by 5 km per hour, the time taken to complete the journey is 2 hours. Find the speed of the train. So let the speed of the train be x km per hour. Correct? So if the speed is x and distance is 300 km, what is the time? So my original time is distance upon speed, right? Now my new speed increases by 5 km per hour. So what is your new speed? New speed is x plus 5. So a new time, suppose this was my original time t, so new time is t minus 2, right? So again, if you just speed into time multiply t minus 2 time multiply by speed, what will you get? The distance. Distance is same, 300. Right? And what is my t minus 2? T minus 2 you can say 300 upon x minus 2. Or you can simplify it 300 minus 2x upon x. Correct? So just putting the values here, then we get 300 minus 2x upon x multiplied by x plus 5 is equal to 300. Okay, taking this x there and then multiplying these two terms, we can get 300x plus 1500 minus 2x square minus 10x is equal to 300x. So this 300x you can cancel, and the quadratic equation will become like minus 2x square minus 10x plus 1500 is equal to 0. So we have got a quadratic equation here. We just need to solve this. Okay, so let us solve this. Now I normally keep my x square coefficient as positive. So if you multiply minus 1 to all the terms, you will get the equation like 2x square plus 10x plus 1500 is equal to 0. Sorry, it will be minus, right? Because I multiplied every term by minus 1. So RHS also minus 1 multiplied by 0 is 0. So it is like this. Now if you divide it the whole term by 2, you can do this. Correct? Now we need 5 from 750, which is 30x minus 25x. Right? So x plus 30 minus 25 x plus 30, so x minus 25, x plus 30 is equal to 0. So x is equal to 25 or x is equal to minus 30, but our speed cannot be negative here. So original speed is 25 kilometer per hour. This is my answer, right? Okay, let us solve another type of distance, speed and time. It is very common problem, right? Very famous also. So the speed of the boat in still water is 15 km per hour. So there is a stream, you can say river, okay, in which a boat is traveling, and in still water means there is no movement of water. The speed of the boat means this is the actual speed of the boat, which is 15 km per hour. It can go 30 km upstream and return downstream to the original point in 4 hours 30 minutes. Now we need to understand what is this term, upstream and downstream. It means the river is not horizontal, but it is like something like this, correct? So when the boat is traveling downwards, it is called as downstream, and of course its speed will be greater than its normal speed. And when it goes upwards, it is called as upstream, and of course its speed will be lesser than its original speed. Suppose the stream is moving at the speed of x km per hour in downward direction. Of course the river will go in downward only, right? So when the boat is coming down, its speed will be original plus the stream speed. Both the speeds gets added here, right? And if the boat is going upward, its speed will decreased by x, right? Remember that you write 15 minus x, not x minus 15, because x will always lesser than 15, right? Because if stream speed is more than the boat cannot travel, right? So it will be like, the x is lesser than 15, so upward speed, this is my upward speed, this is my downward speed, right? So we have assumed, let the speed of stream is x. So my upward speed of boat is 15 minus x, and downward speed of boat is 15 plus x. So what is my upward time? Suppose that distance is given 30 km. So what is my upward time and downward time? Upward time is 30 upon upward speed, and downward time 30 upon 15 plus x. Now as I told you earlier that you can add times. So these two times you can add, upward time plus downward time, and this will give you 4 hours and 30 minutes, because the time taken to complete the journey going down and then coming up, right, is 4 hours 30 minutes. So 4 hours 30 minutes, just add this 30 upon 15 minus x plus 30 upon 15 plus x is equal to 4 hours 30 minutes, means 4.5 hours, which is 4 1 by 2, which is 9 by 2, right? It will be easier to solve like this. So we have got our equation. Now what need to do? Simple. We need to just cross multiply. So make it simpler, what I will do, I will take 30 common from here and bring it there. It will be like 30 1 upon 15 minus x, 15 plus x is equal to 9 by 2, right? Now we can simplify it, correct? Cutting by 3 and then taking 10 here. So you will get, now taking cross multiply and LCM here, 15 minus x, 15 plus x will give you 3 by 20. Here x will get cancelled, right? So let us now solve it here. Like 30 upon, now this is the form of a minus b and a plus b, so what you can do, simply write a square minus b square, which is 3 by 20. Further simplifying, right, and then cross multiply, we will get our equation as 15 square is 225 minus x square is 200. So x square is 225 minus 200, which is 25. X is equal to plus minus 5. We cannot take negative value of speed, so our x is equal to plus 5 kilometer. Right. Okay, let us solve the type 4, which is problem based on ages. The question is, 1 year ago a man was 8 times as old as his son, right? So last year a man was 8 times his son's age, and this year now his age is equal to the square of his son's age. Find their present ages. Okay, so what we can do is, let us say that the present age of son, let the present age of son be x, right? So what will be the age of father? Age of father, because at present it is, his age is equal to the square of his son's age, so it will be x square. So current age of father is x square and the son is x. Now 1 year before, so what will be the age of son 1 year ago? It will be x minus 1, and father's age will be x square minus 1, right? We can reduce 1 year to both the ages, and as per the condition it was given that 1 year ago a man was 8 times as old as his son. So my equation will be like x square minus 1, which is 1 year ago age of father, is 8 times son's age. Simple. So what we can do here, this is a quadratic equation. If you want, you can solve it by multiplying, expanding everything, but another way of doing it, like you can factorize it here only, x minus 1 and x plus 1, correct? Now here you can cancel it, but the only condition is it should not be 0. So we have two cases here. First case, when x minus 1 is equal to 0, or what you can do here is, you can bring all the terms to the left hand side like this, and now take x minus 1 common. You should never cancel the terms immediately, okay? It will lead you to a wrong answer, okay? So try to bring it to the last. So x minus 1 and then x plus 1 from here, and minus 8 from here. So it will be like x minus 1 and x minus 7. So either x is equal to 1 or x is equal to 7. Now it means the sun's present age can be 1 or it can be 7. 1 is not possible. Why? Because we are talking about at 1 year ago, means we are talking about ages of son and father 1 year ago also. And when you take x is equal to 1 year ago the son's age will be 0. It means he has not born yet, right? So it means we cannot take this value. So our value will be x is equal to 7 only. So what will be the father's age? Which is, this is my son's age, this is my father's age. Okay, you can confirm also that 1 year ago son's age will be 6, it will be 48. Confirmation also is there, right? Okay, let us take another typical problem of ages. The question is, 7 years ago Varun's age was 5 times the square of Swati's age. Okay, we are talking about 7 years ago, right? And 3 years hence means in future, okay, after 3 years, Swati's age will be 2/5 of Varun's age. So there is no condition in present age right now. We have conditions 7 years ago and 3 years in the future. So what we will do, we will start with 7 years ago condition. Okay, so let us say Swati's age, let Swati's age 7 years ago, 7 years ago, what? X. Okay, so 7 years ago, let Swati's age be X. So what will be Varun's age? Varun's age will be, or at 7 years ago it was what? Square, 5 times the square of Swati age. So it will be 5x square, right? So 7 years ago we know the ages of Swati and Varun in terms of x. Now 3 years hence, so if you see the gap, okay, 7 years ago and 3 years in the future, the gap is 10 years, right? So after 10 years, you can say after 10 years Swati's age will be x plus 10 and Varun's age will be, correct? So after 10 years Swati's age will be x plus 10 and Varun's age will be 5x square plus 10, and as per the condition it is given that Swati's age will be 2/5 of Varun's age, means x plus 10 will be 2/5 of, like this, correct? So if you simplify this term, right, 5 taking 5 common, we can have 2x square plus 2 and again it will be, so my equation will be like 2x square minus x minus 6 is equal to 0, right? And if you factorize it, minus 4x plus 3x, it will get you x minus 2 and x plus 2x plus 3 is equal to 0. So it will give you what? X is equal to 2 or x is equal to minus 3 by 2. This is not possible. So x is equal to 2. Now this is not our answer. The question was find their present ages. right? So Swati's age was 2. What was Varun's age? So this is Swati's age. Varun's age will be 5x square, which is 20. So the current age or present age, you can say, of Swati is, since it was 7 years ago, so we need to add 7. 2 plus 7, 9, and Varun's age will be 20 plus 7, 27. Right? So this is my final answer, 9 and 27. Okay, let us solve another type of problems which is based on geometry, right? So geometrical shapes will be involved: triangle, square, rectangle, circle, kind of, right? So the question is, the hypotenuse of a right angle triangle is 6 meter more than twice the shortest side. If the third side is 2 meter less than the hypotenuse, find the sides of a triangle. So it is a right angle triangle. So let us draw it first. Suppose this is my right angle triangle, right? Now the hypotenuse of this triangle is 6 meter more than twice the shortest side. So let the shortest side be x. Suppose this is my shortest side, x. So what is your hypotenuse? Hypotenuse will be what? 6 meter more than twice the shortest side. So 2x plus 6. So my hypotenuse is 2x plus 6. Second, if the third side, means the remaining side, is 2 meter less than the hypotenuse, means it is 2 meter less. So it will be 2x plus 4. So my one side is x, the other side is 2x plus 4, and the hypotenuse is 2x plus 6. It's right angle triangle, correct? So we know how to apply the Pythagoras theorem. So let us apply here, which is hypotenuse square is equal to other square, sum of the squares of other sides. Correct? Let us expand it. Will be 4x square plus 36 plus 24x will be x square. Expanding this also, 4x square plus 16 plus 16x. Okay, this 4x square will get cancelled, and let us simplify the other terms. X square I am writing it first, and 16x minus 24x will give me minus 8x, and 16 minus 36 will give me minus 20. So this is my quadratic equation, and now we need to solve this, right? How? We can do this by splitting the middle term. So it will be x minus 10 and x plus 2. So x is equal to 10 or x is equal to minus 2, but negative numbers not applicable. Why? Because it's a side of a triangle. So x is equal to 10. So my shortest side is 10. What will be the hypotenuse? 20 plus 6, 26, and similarly it is 24. Right? So in geometrical shapes, you need to apply whatever formula is applicable. Here it was Pythagoras theorem. Similarly, you can apply other theorem or other formula for similar shapes.